So with this video, I'm going to show you how to plot a function and its tangent line at a given point on your TI calculator here. So this is an idea from calculus. The derivative is the instantaneous rate of change of a function. So the slope of the tangent line is equal to the derivative at a point. And your TI makes this pretty easy and gives you a nice way of visualizing it. So let me show you how to do it. You've probably used the graphing capabilities of your TI before. It's this y equals button. This allows you to define functions on your calculator. So let's just start with a real simple one. Let's do x squared. Um, so this is creating a function variable and storing it in the y1 variable in our calculator. And let's just go ahead and graph it. Let's get a good window. So I got a pretty good one already. So I'm going from -4 to 4 with scale 1, and then I'm going down to -4 and up to +16. So let's see what that looks like. So we get a nice parabola here, and helps to have a symmetric window so you can get a good scale. So this is the capability you're probably familiar with. What I'm going to show you is how to calculate some derivatives with your calculator. So if you go to the y equals, I'm going to show you a way of plotting the tangent line on this curve here, and it relies on an idea from calculus where the slope of the tangent line is just equal to the derivative at that point, and we know the tangent line has to go through a point on the curve. So maybe if I write it out here, it'll make more sense. So underneath math, if you go down to in derivative, so what this does is it will calculate the derivative of a function that you stored in one of your function variables. So you define the variable you're taking the derivative with respect to here, so we're calling it x, and then we're going to pass in the y1 variable. So that is stored under the vars menu here. If you go over to y vars and then function, there's a y1 here. There's another way you can access it. I'll show you that maybe later. And let's say we wanted the tangent line at 2. So we would calculate the derivative at 2. And then, if you remember point slope form from algebra 2 or wherever you encountered that, we're going to take the x and subtract by the value we're looking at, so 2. And then we're going to add the value of the function at 2. So we can use this y1 variable we've already defined. And let me show you another way to access it. So if you hit alpha F4, it brings up this y var menu where you can just quickly access it. So I'm going to select y1 here, and I'm going to pass in, so use some parentheses here, I'm going to pass in a 2. Because I want the value of the function at 2, right? We're looking at the derivative at 2. Yeah, so this will calculate the derivative, and more specifically, it'll give us the equation of the tangent line at x equals 2. So now if we graph, it's going to see the wheel spinning in the corner there. It's getting ready to graph. All right, there you go. So you see the line only touches at one point. Just to illustrate, let's go back to the menu. You can turn off a specific plot here. So just to illustrate the rules we've been talking about, like the power rule, what your calculator is doing is actually a numerical approximation, but we could get it exactly by calculating what the derivative actually is. So let's say 2x. And I want to turn this one off because I want to do the same thing that we did here, but slightly differently. So instead of using this in derivative function on your calculator, you could define the derivative function like I've done here, and then create another function where you use it. So let me show you what I mean. So we want the derivative at, whoops, sorry, I didn't mean to hit that. I meant to hit alpha. Yeah, so we want the derivative at 2. So I'm going to take the function where we defined it, evaluate it at 2, And then I'm going to say x minus 2. And remember, that's just the point slope form. And then we're going to add the value of the function at 2. So we have that stored in y1. I'm going to hit F4 here and select y1, and we're going to evaluate it at 2. So this is the same thing we did in y2, but now we're using a exact value for the derivative. So just keep in mind, when you use this ddx function on your calculator, it's doing some numerical approximations in the background, which for x squared it probably works out exactly, but for more complicated functions that's important. Alright, so let's graph this and see if we get the same thing. Alright, wheel spinning. There it is. So you get a plot containing the curve and the tangent line, and maybe just illustrates before I close out this video. So we can go back to this function and look at the tangent line at other points just by changing the number that we're looking at here. So if you hit insert, and let's change this to like 1, and then delete, and then insert 1 here, and delete, and then insert 1 here, and delete, and delete. Okay, so if we graph this, we should now get the tangent line at 1. Yep, so notice the tangent line is less steep because it's closer to the vertex, so the rate of change is decreasing as you move closer and closer to the vertex here. We'll talk about that more later in class. But this is just to illustrate how we can quickly plot the tangent line of any given curve, right? So we could go back and change this to x to the third. Let me just clear it. X to the, where's the, yeah, there it is, third. And in this case, I'm going to switch back to this because it calculates it in general, whereas this is specifically the derivative of x squared. Okay, so let's graph that, and we should get a tangent line at 2. Let's see. Wheel spinning, wheel spinning. There it is. Took a little bit, but that's probably just because I'm on an emulator here. So this is a pretty nice function of your calculator. Like, we can just quickly change this to whatever we want and get the tangent line at that point. So let's try that again, or let's try sine here. Alright, graph. I probably don't have a good window for sine, right? Yeah, it's being real slow. Let me see if I can hit window. Nope, gotta wait for it. So, some of the pitfalls of the older TIs here. Almost done. Okay, so what I mean by the window there is sine only goes from -1 to 1. -1. Probably, let's not draw so much. Let's go from like -1 up to 1 and graph that. Alright, so that's the sine curve. Let's see if we get... Oh, we were actually looking at the tangent line at 2. Probably not going to see anything. Let me change the window here. This one takes a really long time to draw. There's probably some reason for that. Okay. So let's go to... We can actually probably just use pi, negative pi, and then up to pi. And let's see. Alright, so that's a little better window there. And let's see if we get the tangent line at 2, hopefully. So it should be on the right half right there. You can see the tick mark. The wheel is spinning. There it is. Barely touches it. A long wait for a little payoff, but pretty cool, right? So you can quickly change this function and get the tangent line function. Yeah, so there you go. Pretty cool.